now we're just going to practice finding the first order partial derivatives with some different types of functions. All right, so the first function here is a polynomial type. All right, so it's a lot like the example that I did to start off. All right, so I want to find both. So I'm just going to use the function notation. So I'm going to find f sub x, then I'll find f sub y. All right, so first the derivative with respect to x. So basically what you can do is I can only take a derivative where there's an x value. If there's no x value, it's constant. All right, so these are the only functions that have x values, which means that will zero out and that will zero out. I don't really want to x them out because I'll need them for the next derivative. But that's the first thing I sort of do is I only take the derivative of the part with the variable I'm looking at. All right, everything else will zero away. So the 3y will zero away because there's no change in x. 12 is a constant, there's no change in x. Alright, so I only take the derivative of the first four expressions. Alright, so the derivative with respect to x for our 0.3x cubed, well, that's just a power function. I get 0.9 x to the second minus, and you just kind of get used to the mixed variable. The x is what I'm looking at, right? I'm looking at the x part. The 5 and the y are constant multipliers, so they come along. So 5y, take the derivative of x, which is 1, and I'm not going to write it down this time. Alright, I get negative 5 times y times 1, which is just negative 5y. The derivative of 2x squared, well, that's just the power of 4x to the first, and then the derivative of negative 5x is just negative 5. And again, like I said before, the rest will zero out. Alright, so there's the first order derivative with respect to x. Now the first order derivative with respect to y. So the y, again, is a lot easier. There's actually only two parts to the y. This is the only part with a y, and that is the only part with a y. Everything else doesn't change when y changes, right? If I change the number of, so the idea is, if I'm looking at a point on my curve, x is staying whatever x is. So if it's the point 2, 1, x stays 2, but the y variable 1, I'm looking at the slopes near it, right? As I approach that 1, and the 1 would change. And so if x is not changing, it's being held constant, and all of those parts don't matter. They zero away. And so I only look at the y part. So there's only two parts with y in it. Everything else is a constant that zeroes away. It's not changing. And so the derivative of negative 5y with respect to y, well, the negative 5 is a constant that comes along. X is the constant multiplier that comes along. The derivative of just y is 1. So it would be negative 5x times 1, which is negative 5x. And then the last part of that is the derivative of 3y. Well, the derivative of 3y is just 3. And so there, and again, the derivatives are very different, right? The derivative with respect to x is a lot more complicated than the derivative with respect to y. And you'll notice the derivative with respect to y actually has no y part in it, which again can happen. All right, let's do the second example. All right, so again, function with respect to, so this is another polynomial type. So the function p with respect to x and the function p with respect to y. Alright, so again, when I'm looking at the x, I only look at those where the x parts. Alright, those three values have x parts. Everything else, there's no x, so there's no change. So the 6y squared zeroes away, the 1600y zeroes away, and the 80,000 zeroes away. And so I just take the derivative of those with respect to x. So I get a negative x to the first. And remember, this is that mixed variable, you're always going to get the same thing. You're going to get the 4 and the y come along. The x is the derivative of x is 1. So it's negative 4y. And then the 1920, right, the derivative of 1920, x is 1920, and so there's the derivative with respect to x. Alright, now the derivative with respect to y, so again, I only look at the y parts. That's it. Those three values are the only values with y, everything else zeroes out. Those are the only things that are changing when y changes. And so the derivative of 6y squared is going to give me out a negative 12y to the first. And then my mixed derivative, remember I'm taking the derivative of y, which is 1. The 4 and the x are constants that come along. So negative 4x times 1, which is negative 4x. 1920 zeroes out, then I get my positive 1600, and there's my derivative with respect to y. Alright, we'll stop there. I'll pick up the next examples in the next video.